Dzień dobry, witam Państwa serdecznie na 7. edycji Edward Altman Lecture Series. W tym roku zajmiemy się uczeniem maszynowym i sztuczną inteligencją, czyli tematem bardzo ważnym i bardzo popularnym. Na początku poproszę o zabranie głosu naszego prodziekana, pana doktora Michała Matusewicza, a potem przedstawię Państwu przebieg całego wydarzenia i powitam także naszych panelistów. Gościem 7. edycji jest profesor Sanjiv z Santa Clara University. I can say good afternoon, but I know that in California it's early in the morning, so it's 6 o'clock in the morning. So we should say good morning, Sanjiv. We are very happy to have you here with us. First, I would like to ask my colleague, Deputy Dean of our Collegium, Dr. Michał Matusewicz, for official opening of this event, and then I will briefly describe, let's say, the flow of things today.
Dzień dobry, dziękuję pani profesor. Szanowni Państwo, chciałbym w imieniu swoim oraz dziekana Kolegium Zarządzania i Finansów, pani profesor Joanny Wielgórskiej-Leszczyńskiej, serdecznie powitać wszystkich panelistów i wszystkich uczestników Edward Altman Lecture Series. Bardzo się cieszę, że możemy się spotkać już po raz 7. I bardzo się cieszymy się, że inicjatywa, która została zapoczątkowana w 2016 roku, czyli 7 lat temu, jest cały czas kontynuowana, jest miejscem, gdzie można przedyskutować praktyczne problemy związane z funkcjonowaniem gospodarki, rynku finansowego z gronem wybitnych i doświadczonych ekonomistów. Ogromną też wartością dodaną tych naszych spotkań jest to, że możemy gościć wybitnych naukowców ze Stanów Zjednoczonych i w tym roku jest to pan profesor Sanjiv z Santa Clara University. Nie przedłużając, życzę Państwu ciekawych i owocnych dyskusji i obrad. And I would like to say a few words to our guests from United States. I would like to say hello. Good morning, Professor Das. Thank you very much that you are with us. It's a great pleasure and great honor for us that you are here. Thanks a lot. And the problem which will be discussed are very important and topical. And I wish you a very fruitful discussions during these few hours. And I think that all of us will enjoy the conference. And I hope in the near future we will have opportunities to meet here in Poland face to face. Remember that all the time you are very welcome here. All the best and thank you very much. Thank you.
Dziękuję panie dziekanie. Teraz zgodnie z obietnicą parę słów na temat dzisiejszego wydarzenia. Jak już wspomniałam, gościem honorowym, keynote speakerem jest profesor Sanjiv Das, który jest także członkiem Rady Naukowej Edward Altman Lecture Series i co więcej gościł już na SGH w 2014 roku podczas International Risk Management Conference, którą wtedy SGH współorganizowała. Także można powiedzieć, że też ma z SGH już taki kontakt nie pierwszy raz, z czego się bardzo cieszymy. Po wykładzie profesora Dasa, który będzie trwał mniej więcej 50 minut, będzie czas na sesję pytań i odpowiedzi, zarówno ze strony naszych panelistów, których za chwilkę przedstawię, jak i ze strony publiczności, która jest na online, jest czat, można próbować przez ten czat zadawać pytania. Będzie to, można powiedzieć, okazja, jedna z nielicznych, żeby wejść w taką bezpośrednią interakcję z naszym keynote speakerem. Po wykładzie i po sesji pytań i odpowiedzi odbędzie się dyskusja, możemy powiedzieć, że debata moderowana przez panią profesor Annę Matuszyk z SGH z udziałem naszych wyśmienitych gości. Pani doktor Elizy Kruczkowskiej, dyrektora w Polskim Funduszu Rozwoju. Dodam również, że Polski Fundusz Rozwoju jest partnerem tego wydarzenia.
Dzień dobry Państwu, dziękuję za zaproszenie.
Cieszę się, że pani dyrektor do nas dołączyła. Kolejnym panelistem jest pan profesor Przemysław Biecek z Politechniki Warszawskiej, ekspert z zakresu sztucznej inteligencji. Witamy serdecznie. Kolejnym panelistą wymieniam według alfabetu jest pan Michał Nowakowski, znany medialnie spec od fintechów i także sztucznej inteligencji, bardzo aktywnie działający w tej sferze. I ostatnim panelistą, last but not least, wybitny ekspert Biura Informacji Kredytowej, pan dr Piotr Wojewnik, który także ma okazję prowadzić zajęcia na studiach podyplomowych SGH. W tak wyśmienitym gronie odbędzie się debata po wykładzie profesora Sanjiva Dasa i też jeżeli będą pytania na czacie, to zachęcam do tego, żeby z tej opcji skorzystać. Publiczność ma możliwość zadawania takich pytań. So, dear Sanjiv, welcome again. We are happy to host you again in Warsaw after 9 years of your first visit. I wish you the best possible audience with very active questions, with very good questions, and the floor is yours.
Got it. Okay, terrific. Thanks so much, and hopefully everyone can hear me just fine, and the echo has vanished, so I think we're in good shape. All right, so this is a whole line of research I've been working on for the last 4 to 5 years. I've been working on this at the university and at Amazon. So AWS is Amazon Web Services, and I'm required by them to say that all the opinions I express here are my own and not those of Amazon. So what I will be doing is talking about the ML-verse, which is the machine learning universe, and the industrialization of machine learning. I'll talk a little bit about multimodality in machine learning, which is the use of multiple types of data for machine learning purposes. We'll talk about the revolution in generative AI, which is happening as we speak in the last few months, and I'm sure everybody in Poland is excited about this as well. I'll talk about how it gets democratized, what are transformers and how we've been adapting them to do financial modeling. Look at the emergent properties of foundational models. Foundational models are very, very large neural networks that are now performing incredible things. And then we'll talk about like where all this is probably going to go in the finance world. So to begin with, we can talk about the definition of the ML-verse, or the machine learning universe. And it's really something that characterizes the fourth industrial revolution. So we've had 3 previous industrial revolutions from the steam engine onwards. But what's really happened now is that the AI and machine learning revolution is sort of creating a completely new set of outcomes and tasks, and we'll start looking at how those play out in the financial and economics world. Machine learning is specifically the subfield of AI where computers are learning without being programmed explicitly. So we've gone away from rule-based systems to data-driven pattern recognition systems. ML industrialization is more of a standardization that's happened over the last 3 to 5 years with pre-configured customizable architectures that enable everything from data preparation to the interfaces to training models to deploying them in automated, repeatable, scalable, integrated, and reliable ways. Okay, so you want to have all these 5 things take place for the machine learning industrialization to be complete. And they should also be satisfying sort of the needs of different people, from financial analysts to sort of technical engineers and so on. And finally, democratization is taking place, and I'll show you what I've been doing to democratize machine learning. But the definition of democratization comprises 3 things. We want to have a high level of education amongst users so that everybody can use machine learning. It should be accessible, so open source and standardization is very, very important. And finally, it should just be user-friendly so that people can use it without too much effort. What I want to focus the talk today on is actually one attribute of all these things, which is multimodality, which is using data from many, many different sources to expand the kind of decisions we make as economists and finance people. Okay, so hopefully the theme of this will come through when I finish sort of with the entire presentation. So about 10 years ago, Google put out a paper, and the paper is called The Unreasonable Effectiveness of Data. This is sort of a riff on Eugene Wigner, who got a Nobel Prize in physics. His paper was called The Unreasonable Effectiveness of Mathematics in the Natural Sciences. And we started learning with machine learning that large amounts of data were also becoming unreasonably effective through pattern recognition. So we've sort of seen this revolution over the last 10 years, and it's becoming more and more multimodal. Okay, so if you look at a trader who's in the financial markets, they're looking at different types of data. They're looking at tabular data, which is standard databases, Excel spreadsheets. These are, columns of numerical and categorical data. But they're also looking at stock charts and images, which are sort of computer vision related problems. They're also looking at a whole bunch of news feeds and texts and analyst reports. So there's text involved as well. And then they're listening to the news as well. So there's audio. Okay, so you have all kinds of different modalities. And what we wanted to do was sort of build models that actually take care of this. Okay, so traditional econometrics works mostly on tabular data. We haven't sort of, you take sort of large stats packages, they usually work on tabular data. Machine learning has been super successful on tabular text image data, but mostly in a unimodal setting. What's different is that human beings actually do not make decisions in a unimodal manner. We sort of make decisions in multimodal ways, and we tend to be multisensory in the approach we take. So if you went back to the Bible and looked at Genesis, you'd basically see that, humans wanted to make, sort of God in our own image. So here we want to make machines in our own image. And by and large, the AI revolution has been characterized by a lot of data that's used to actually train single models. And the criticism has always been that how come children don't need so much data to become really, quick at learning? And the argument has been that children are really multimodal learners. They learn from the context of different modalities like image, their eyes, they hear, they see, and they compute. Whereas machines were only looking at one of these modalities at a time, and therefore weren't as good at quickly learning the context in which to make a decision. Okay, so when we go from unimodal data analysis to multimodal data analysis, we're sort of behaving in the way children learn, and hopefully we need a lot less data to actually make these decisions that we have. So there's a collection of academic research that is out on Amazon Science website. So this is available openly. So these are just a small collection of papers behind the talk, so people can go and look at it. And everything I've built is completely open, and it's available here. So if you click on this, you will find all the sort of different things. We've got a separate software development kit that actually runs many of the analysis that I'll be talking about today. There's a whole bunch of solutions like credit scoring solutions, using graphs to actually do machine learning, specialized financial language models that have been tuned on a whole bunch of financial text. And then there's a bunch of notebooks and other sort of collateral like blogs, research papers, and there's even sort of documentation to do a lot of the work here. So you can get a documentation to pull down SEC filings, to summarizing, training, and so on and so forth. Okay, so there's a lot of material. I'm happy to send the link out. If you email me, I can get it to you. And it's all publicly available for people to use. So what are the big game changers? The big game changers have been a bunch of mathematical innovations from the 1980s in sort of computing architectures and in neural net architectures. Okay, so we've had everything from LSTMs, which are long short-term memory neurons, to the current wave of transformers. And the one on the right is basically the BERT transformer that actually does most of the heavy lifting that we're seeing in modern sort of deep learning. The second big piece of the puzzle has been big data. We've had this going on for 10 to 15 years now, and people are curating more and more of this. NASDAQ, for example, has made a big investment in large amounts of data providers. They're buying up companies that actually provide all kinds of data. And NASDAQ, in fact, has pages on their website that talk about how to do machine learning with NASDAQ data. So that's the second piece of it. And the third piece of it is actually hardware. And we're finding a lot of interesting hardware that's being built specifically for doing machine learning. So the basic idea here is that when we do sort of neural net computations, we want to do large amounts of matrix multiplications. And matrix multiplications can be parallelized on chips very effectively. So GPUs, graphic processing units, are much more effective at doing matrix calculations than standard CPUs that you get in computers. And so the demand for sort of GPUs has skyrocketed. And everybody, in fact, today there is a shortage of graphic processing units in the world just because of this big AI revolution. The basic trade-off really is that a CPU has a very high clock speed and computations are done very, very fast. but it has very few cores on the CPU. So the amount of parallelism you get is very little. On the other hand, GPUs have a lower clock speed, but they have many cores, and so you can parallelize a lot better. So there's a trade-off between the speed at which the chip is working and the number of parallel processes it's entertaining. And the combination of those two generates a lot of heat on the chip. And so you kind of trade these off when you go from a CPU to a GPU. And then, of course, Google, for example, has created TPUs, which try to optimize this trade-off. Amazon has chips called Trainium, which also do optimization of this trade-off. So there's a big hardware revolution also that is sitting behind this AI revolution. I'm going to start at the very beginning. In 1994, the first paper that used neural nets was published at MIT by Andrew Lo and his co-authors. And the idea here was to train a neural network to do option pricing, to learn the Black-Scholes equation for option pricing. Now, it turns out you can do this today with today's tooling in almost 3 seconds. The whole thing can be trained in 3 to 5 seconds, extremely fast, and you need very little sort of work to get this done. So for example, that's the Black-Scholes equation. The only finance you need is to normalize the prices of options. So if I collect a big data set of option prices in the world from various companies, and I have all the inputs to the option prices, I'm basically collecting this data from the market. If I pull this data in from the market, I take 300,000 options, I can basically fit a neural net to this, and the neural net will learn the option pricing model that the market is using. So the code you need is basically 10 lines of code. It's a very simple neural network, and you can train it in about a couple of seconds. You can see I've done 10 rounds of training. And when I test it in sample, I will get the actual price versus the predicted price on a 45-degree line. The error is extremely small. And what this does is literally, without having to take a single economics or finance class, a computer scientist can train a neural network to price options with very high accuracy in sample. You get exactly the same accuracy out of sample. And the out of sample accuracy is equally high because the model that the market is using is not changing from day to day. And so you get exactly the same result. Okay, so this is an interesting thing. You can use different techniques like random forest. You also get the same 45-degree line between the actual price and the predicted price, and the percentage error as well as the mean squared error is extremely small. So you can effectively learn the model the markets are using to price options every day, every hour, in a few seconds, and use it for trading. So that is one way in which you can take machine learning and use a large amount of data to train it. Here's a second application. The second application is to venture capital. What we did was we took a huge amount of data from Crunchbase, which is an open source repository of all the data on startups in the startup ecosystem. We then took the patents data as well. So there's text over here. There's tabular data here. We combined the text and tabular data into a database. We featurized it and got a whole bunch of variables. And then you're able to actually predict whether the startup will fail, whether it'll have an IPO or it'll get acquired with about 88 to 90% accuracy. Okay, so a very high level of accuracy in a multimodal setting to actually predict whether startups will succeed or fail. And you can also predict whether they will get follow-on funding. What this does is a model like this can help VCs decide which of the startups they want to focus their limited time and attention on, while discarding a whole bunch of the other startups. And this is sort of multimodal because it's combining text and tabular data. So these are just two sort of examples. The third example that motivates multimodal machine learning is image recognition. So here's the classic MNIST database. So the classic MNIST database is for image recognition of digits. So when you write a check and you put in the amount on your check, you basically type in your digits, like maybe the check is for $300, you write in $300, the OCR technology will scan the check, it'll pick up each of the individual digits, and each of these digits then will be put into a small pixel frame like you're seeing over here. So the 0 here is in a tiny pixel frame, and that 0 is put into a pixel frame that has 28 pixels across and 28 pixels down. So that gives you a total of 784 pixels per pixel frame. Each pixel frame is then code it from 0 to 255. If there's no ink in that little pixel, the number 0 will be given. If the entire pixel is filled with ink, it will have the number 255. So if you look at the data set here, every digit is across the row. There's mostly zeros in it because a lot of the pixel is white space. The rest of it has ink in it. And so there'll be a bunch of numbers, 784 numbers representing that digit. And the exercise is, can you recognize which of these digits it is? There are 10 digits. And so you kind of have 10 of these numbers, and you want to sort of build a model to decide whether it's a 4 or a 3 or a 6 and so on. So you could do things like multimodal, logistic regression, and things of that, multinomial regressions. But the best way to do this is with machine learning. So it turns out this problem has been solved to about 99.9% accuracy with machine learning. Now, what if I wanted to use the same problem to predict whether the stock market index will go up or down tomorrow? So the way we do that is we will actually create a data set. And we did 55 years of this data set. And we took all the stocks in the S&P 500 every day. It turns out there are 5,370 stocks in the S&P 500 from 1963 all the way to 2016. Each of these stocks, we get the returns. And one way to construct an image of the stock market is to actually take today, if you're sitting here today, we go back 30 days. And for all those 30 days, we have 500 return values for each of the stocks in the S&P 500. So 500 multiplied by 30 is 15,000 numbers. And you can think of those 15,000 numbers as pixel values in an image. So every day I can look back 30 days and construct an image of the markets made up of 15,000 pixels. If I go back 55 years, I get about 14,000 images of the market. Now I can train a computer vision model to actually go ahead and detect whether the S&P 500 on the next day will go up or down based on the image that I'm seeing on the previous day. So to do that, I have to worry about a 30-day period. And in that 30-day period, you might have, for example, some days when the stock went in and out of the index. So the way to fix this problem is to take the 500 returns on any one day, convert them into 19 percentiles over the distribution of returns for the day. 500 numbers gives you a distribution, and then pick off the percentiles that you want. Okay, so we featureize the data down into 19 percentiles times 30 days. So we effectively get an image every day of the markets looking back 30 days of 570 pixels. We fitted that rolling regressions over time, and it turns out that you can predict whether the stock market will go up or down on the following day with about 60% accuracy. So you train on 5,000 images and then try and go out of sample for the next 5 days, you get an accuracy of 60%. If you go out of sample for the next 10 days, you will get about 58% accuracy. And if you go out of sample about 30 days, you get about 55%. So is this good enough? So is 60% good enough for me to actually make profits? And the question really is what percentage of the days does the market go up versus down? And it turns out that the market goes up. The S&P 500 over the last 55 years has gone up 52.7% of the days and down the other, one minus 52.7%. So you compare 52.7% with 60.5% and ask yourself, is that enough accuracy for me to actually make money day over day? And it turns out after transaction costs, it's pretty hard to make money. What we've really done here is created a test of market efficiency, not on a single univariate series, but a test of market efficiency on an entire series of stocks, 500 stocks in particular here, to see how it's doing. Okay, so deep learning is the only one that gives us the high level of accuracy. This 58% corresponds to the 10-day forecast period here, and we basically get about 58%. None of the other standard methods actually gives you any accuracy whatsoever. So this forecasting problem is pretty nonlinear, and that's why deep learning actually does a pretty good job. Okay, so that's just a basic introduction to the different types of examples where multimodal machine learning can be used. And if you can start thinking about stock prediction problems as image classification problems, you get insights that might be quite different from traditional econometric techniques. So I want to make this distinction now between two types of AI. the discriminative machine learning that we do, which is standard, which is sort of the classification where we're trying to predict a variable y or the probability of a variable y given a bunch of x variables. And today's world, we're sort of dealing with generative AI, which is really the opposite. That is, you're given something and you're trying to predict the data that would generate that prediction. Okay, so we're in the world of both these now mixed, and it's become fairly interesting to see how things are evolving. So the timeline here has become extremely fast. Okay, so OpenAI launched GPT way back in 2018, 2019. Then in 2019, we got GPT-2. Google came out with T5. We got GPT-3. And now we've actually got GPT-4 and so on and so forth. So if you look at the timeline, in 2019, we got BERT, which is the early versions of these transformer models. And 2011, there was Watson. So we've had very, very slow progress up to 2019. In 2020, we got 4 generative models that are pretty big, GPT-3 included, with 175 billion parameters. In 2021, we launched, there's so many more models that came out. 2022, you can see the number of models that came out was even larger. And it's become basically an arms race. 2022 continues. We've got a whole bunch of things like Palm, Bloom, and so on. Right now, in 2023, just in the first 3 months, we've got these many large language models that have come out. And finally, all the way up to the end of April, we've got another bunch of models. Okay, so the pace at which these models are emerging is completely outstripping our ability to sort of keep up with these large models. Okay, so here is sort of the tree of these large language models, and we're kind of living in this space up here with Claude, GPT-4, Bard, and Jurassic 2. And I'll comment on all these as we get into this talk. Okay, so I just want to give you sort of a sense of the landscape and how multimodal machine learning is done. When I joined Amazon, we started building these things out. And these are built into a product called Amazon SageMaker Jumpstart. And you just have to go to Amazon and log in, and you get a whole bunch of these things. You go into Jumpstart, and you can look at all the different cards that have been built there. These cards offer you sort of pre-built solutions that you can use. So if you went in here, for example, I can just show you the screen. This is the Jumpstart screen. And if you land up here, you can search for models. So for example, if you just type in finance, you'll start seeing a whole bunch of things to do with fraud detection, text embeddings, payment classifications, credit scoring, and so on. And you can click on any of these cards and get an entire solution and deploy it to an endpoint. Over here, you can see all the foundation models, the large language models that do these very big things like generate images, text to text, and so on are all available. So if you just click on any of these, you can click through, deploy the model from here, and then start using it right away. Okay, so all this has been built for finance purposes and economics purposes. We have a whole bunch of cards, and this is a small selection of those cards that also get used. Okay, so let me talk about how multimodal is done first with just a combination of text and tabular data, and we'll talk about the results that we have. So over here, you can see that this is a sample workflow that somebody might want to use. You can start by downloading a whole bunch of text from SEC filings. This is very high quality text because companies are required to report everything to the SEC or the regulator. These get reported, and you get a whole bunch of SEC filings in a data set. One of the things I wanted to do was build an API that allows you to download these filings in one single function call, so you don't have to waste a lot of time collecting the data. Once you've collected the data here, then you can join it with your tabular data. So you might have stock price data, balance sheet, and income statement data. You join it. So now you've joined tabular data and textual data, and we call that tab text. Tab text can then be processed automatically with another API that will add scores for all the text. So the positivity of the text, negativity, sentiment, polarity, all this gets added to the text automatically. Now you have a very big data frame that contains columns of text, columns of tabular data. And that data frame is called tab text enhanced, which can then be passed to a machine learning model to fit it. Now, you can't do this with econometrics. In econometrics, you basically have to have tabular data. In machine learning, you can have columns of text, you can have columns of tabular data, and you can basically use the tooling that I'm going to show you to build a model with just a click of the button. Okay, and I'm gonna get there. And once it's done, you want to actually explain the decision made by the machine learning model. So I'm going to talk a little bit about FinTech. So we realized that SCC data was extremely popular. This paper, for example, was written in 2020. It reported that the 10K and 10Q filing. So every company in the United States has to file a quarterly report or an annual report with the SEC. This is, hundreds of thousands of words. And this is roughly of the size, just the management discussion section is about 5,000 words on average. But the number of downloads of these by machines in 2016 was 165 million. And today that number is well over 200 million. So more than 200 million machine downloads of the text of the SEC filings takes place. And there's a whole bunch of other types of filings that hedge funds and other people are actually processing using machine learning. We wanted to make this really easy to do. So there's a card in the Jumpstart ecosystem. What it does is it allows you to sort of stipulate which ticker symbol you're interested in. You can say which forms or which filings or which reports that are filed with the SEC you're interested in. You can give the date range and you just click on it and it goes off and pulls in the data set. So once you run this, 5 minutes later, you'll get an entire data set with each of the filings in a row. And those filings will have the full text of the filing, the management discussion section, the risk factors section, controls, executive compensation section, and so on. And this entire data table of text becomes available for you to do machine learning with. Now you can do various things with it. You can score the text. So there's another API that we've written that you can point to a single column in your data table of text and it will automatically score it. So for example, if I have a column of text with a management discussion for Google, Netflix, Facebook, and so on, it'll automatically take the text and add all these extra columns to it with these scores. So this is the positivity score, the negativity score, certainty, risk score, litigious score, polarity, readability, and so on and so forth. Readability, for example, is an interesting statistic that people compute because the literature has found that the less readable the filing or the management report is, the more likely the company will perform worse in the next 2 earnings quarters. Okay, so companies that have bad news tend to write more complicated and confusing text in their reports, and the readability score tends to be higher. The readability score, so 21 says that you should have 21 years of formal schooling to be able to read this particular document. Okay, and that's what this readability score is. So you can actually have a table like this with the text in it, and you can have the scores, and you want to sort of build models on tables of this sort. The other thing you could do is you could summarize it. So there's another API which allows you to summarize it. So over here, notice I'm pointing to the text column in this data frame, and I'm asking it for a summary. It'll basically put the summary on the right-hand side column. Now, why was this important for machine learning? For machine learning and building models, you can build models on the text, but the text can be very, very noisy. And because the text is noisy, the problem you get into is that the noise sort of makes the model sort of worse. So what you could do is summarize the text. And when you summarize it, you're getting rid of the redundant text and keeping the main theme of the text. And hopefully that improves the quality of it. Okay, so one idea is summarize it and then train your model on the summary, and that sort of reduces the noise. The flip side to that is when you do a summary, you throw away a lot of the text. And when you throw away a lot of the text, you lose context. And so for certain types of data, the trade-off between context and noise through a summary is actually good. That is, by summarizing, you're reducing a lot of the noise, and the amount of context you lose is small, and the models tend to be better. In some types of data, you lose too much context, and you don't reduce the noise too much. Those models generally tend to perform worse if you train the model on the summary versus training it on the text. Okay, so, but the idea here is that you want to train models on text and tabular data together. Now, how do we actually score the text? The way we do it, we published a paper last year called FinLex, and the idea was we want to create word lists that can be used to sort of look at the proportion of the text that's related to a concept. We wanted to do it without any human intervention. We wanted the machine to build a word list. We wanted the concepts to not be in the Harvard Inquirer. What people and economists generally do is they build word lists that are based on the Harvard Inquirer, which is about 30 years old. It's a list developed by the psychology department at Harvard for sentiment scoring of different documents. Now, the problem with the Harvard Inquirer is that it's basically based on words that are similar to sentiment like happiness, sadness, positivity, negativity, and so on. But there might be text where words occur with words that reflect a particular sentiment, but they don't actually mean that thing. So, for example, you might want the happiness of the text, and there might be words that co-occur with happiness but don't actually mean happiness. Machine learning actually picks that up really nicely. So, for example, we built a system that will take all the words in English and find all the words that are related to the concepts of fraud and negligence. The machine takes about 2-3 seconds to generate a word list like this. The way it does it is you create a vector that represents every word in English in high dimensional space, usually 300 dimensional space. And every word then becomes a point in 3-dimensional space, and there are clusters of words in this high dimensional space that occur in the neighborhood of the words fraud and negligence. These are the words that occur in that neighborhood. And when you print it out, you find you've got 200 words that are sort of reflective of the concept of fraud and negligence, and you can use these words to score the text that you have. I asked some of my lawyer friends to give me words that occur in the context of fraud and negligence, and usually a human being can kind of write out 30 to 40 words quite quickly, and then your brain sort of doesn't pick up any more of these. The machine actually generate 200-300 of these with within a few seconds, and it's extremely powerful. Now, is this effective? So we did some testing, and it turns out if you look at the financial phrase bank data set, which is a collection of financial news, it comes with a tag. Each of the news articles comes with a tag that is positive, negative, and neutral, and you fit a machine learning model to this. The way you do it is you take the Loughran-McDonald word lists, which are based on the Harvard Inquirer. You score the text for different attributes, and then you use that numerical data that you've created from the text, and you get about 65% accuracy on prediction of the sentiment. The FinLex, which is the new things we created, gets you up to 70%. But in fact, if you use the whole text as it is, you'll get about 81% accuracy. So the first principle is using the whole text actually gives you better performance, and you don't even need these word lists. And if you combine text and tabular data, you can do even better. Now, I talked a lot about creating these word lists for machine learning. Today's world is completely different. You can go to ChatGPT or Bard or any of these large language models and just ask it to generate 200 words related to the concept of fraud and negligence. A couple of seconds later, you get 200 words like this, and then you can, curate it. So this is the rate of obsolescence. We published the paper for FinLex for creating these word lists just last year. Within a year, with these generative AI models, the entire thing has been completely obsoleted. Okay, so what I want to do now is talk about how credit ratings take place. And credit ratings are done in a sort of formal process by the rating agencies. So what the rating agencies do, and they've had neural networks and sort of deep learning models for a while. They'll take a neural network model, train it on tabular data, and predict the probability of default of a company, and then translate that into an initial rating. Okay, so the machine comes up with an initial rating. The next thing they do is a bunch of 3 or 4 to 5 analysts will get into a room. The rating agency will then, read documents and other things that relate to the rating and decide whether the rating that was given by the machine should remain as it is, or they should notch the rating up and down. So the language part of the modeling is done sort of in a human way, whereas the numerical part of the data is handled by a machine to create the initial rating. The third step is once they decide on the credit rating of the company, they then have to sort of write a story or an explanation that explains the rating. Now you can do all these 3 things with machine learning. You can have more accurate models when you combine the text and numerical data that you have about a company. You don't need a human to build that model, and the machine can also write the explanation. So we did this as an example. We took 25 standard financial indicators that are used by, for credit scoring companies, liquidity ratios, profitability ratios, debt ratios, cash flow ratios, and so on. We collected a data set of these. The number of firms in the data set and the proportions of them that fall into each rating category are shown here. This is reflective of the distribution of ratings in the United States. We collected the industry code and threw it into another column. We also collected the ticker symbol and put that into another column as well. And the ticker symbol should not be a variable that you want to use, right? Because it's just a string of characters, and why would that help with actually credit scoring? But it turns out we know that credit ratings migrate slowly. They do not actually go suddenly from AAA to C. And the ticker symbol actually is a way the machine learning model can anchor to the previous rating and not let it migrate too fast. Okay, so the ticker symbol actually improves the accuracy of the model quite a bit. We also added into a column in the data set the entire management discussion and analysis. So the entire annual report sort of goes into another column, and we call that tab text. Then we point to the SEC text, and we generate the 11 scores, and we get a large data set that contains all these 25 variables, the industry code, the ticker symbol, the full text, as well as scores for fraud, readability, and so on and so forth. And the question is, can we get a better credit rating model when we added text to it versus not? So you can do different experiments. One experiment is, can we do binary classification, investment grade, predict whether the company will be investment grade versus below investment grade, and then predict the actual rating category of the company. So we do this in a formal out-of-sample way. It turns out that we need a lot of machinery to actually fit a model to a large data set that has columns of text, tabular, and categorical data. So the way this is done is using something called AutoGluon from Amazon. This is an open source project, which highly encourage everybody to take a look at, because you can actually train models on data frames that have text and tabular data. It's totally multimodal. In fact, you can even train a model on text and tabular, plus if you have a column that points to images on your drive, it will also use the images to fit a combined machine learning model. So how does it do it? If you look at the diagram on the right here, it's going to take a bunch of inputs. Some of the columns are text, some are tabular. The columns that are tabular will go through a bunch of models. Some of the models are highlighted on the left here. So we'll pass the numerical data into machine learning models on the right. We'll pass the text data into transformer models like BERT type models. These transformer models will convert the text into vector representations or embeddings. Those embeddings will then be concatenated with the outputs of these models and the original input. So you get a much bigger concatenated representation of both the text and the tabular data together. Then that larger representation, which is completely numerical, will be passed through a bunch of models, model 1, model 2 to model n. So all these different machine learning models are trained in parallel. The outputs of all those models are a probability of being, say, above investment grade or below investment grade. And then those models will be weighted by another neural network layer here. So this blue layer called weighting is actually a bunch of neural network layers that optimally provide weights to each of these models. And finally, the last layer will generate the final prediction of the model. We train the entire stack, and you can have multiple stacks and multiple of these input stacks. Train the whole thing at one go, so all the parameters are tuned at the same time to generate one very large model. And that model tends to have a very high level of accuracy because we've ensembled a large range of models. So if you look at what we get, we basically find that the numerical models are extremely accurate. Rating agencies have tuned it to about 84% accuracy. So there's about a 16% error. And then with the additional properties of text, you can go all the way up to 87, 88%. So you're basically getting rid of about 25% of the error by adding text to the model. It's even better than that, because you can see that the prediction, the confusion matrix here is the predicted values on the left on the rows and the true values on the columns. You can see that the diagonal is very heavy, so the accuracy is pretty high. But even when you get it wrong, you're really off by just a single rating. You're not off by a lot. And if you allow for one rating error in the credit classification, then you have basically almost 95% accuracy from the combined text and tabular models. When you do it with tickers, you can go from about 88% to 90% as well. Okay, so the additional of the ticker or the anchoring variable does a really good job. So the whole point of this is that you can actually do credit ratings now, not just on tabular data like the way we were doing before, but you can add all the text you want in and make this a lot more viable and interesting. In fact, Ed Altman has a company called Wiser Funding, and WISER funding does lending in markets outside sort of the developed countries. So like in India and China, for example. And over here, the quality of tabular data tends to be poor, unlike in the United States. But you can collect a lot of textual data like email traffic between you and the borrower and so on, and add that and do the whole thing multimodal to get good models for this. So multimodal machine learning will help lenders in developing countries offer up their text and perform better as well. Here's another application that's multimodal. What you can do is you can take the SEC filings. So if I look at the management discussion section of all the companies' reports with the SEC, I can process that into a single vector that represents the text in that discussion. Now, two companies that are talking about the same risks going forward, the same profitability ratios and things going forward, those companies are likely to be affected by the same risks. And so we will construct a network where every node in this network is a company, and companies that are very similar in their discussions will be connected with a link. So we can construct an entire network of companies using the text of the SEC filings, and then take the entire tabular data, like all the balance sheet income statement data that we have in our table, and add this to the network, put the two things together. So think of a network where every node is a company. At every node, there's a big column of numbers that contains all the balance sheet and income statement data for these companies. And now I want to run machine learning on that particular object, which is no more a table of data, but it's a network plus a table of data. That's called graph machine learning. It's been around for a while, but we built a solution to do that. And it turns out you actually get better credit quality models if you train models on both the graph and the machine learning, and you can see the results down here. Okay, so all these models are kind of deployed in SageMaker Jumpstart, and you can go in here and just look for graph-based machine learning. Graph-based credit scoring is here. You can click on it. You can launch the solution and use that model automatically with your data. Okay, so the idea here was to actually build models that you can work with automatically. These models result in a demo like this. It has, so for example, we took Ed Altman's a model, and we took the same ratios that Ed usually uses, but we added the text over here. And basically all this code, you don't have to change anything, you just run it. So really you can see here, Ed has 5 ratios in his very famous credit scoring model. We add the industry code, we add the text, and we add the ratings, and we fit a model so that it can predict the ratings. And if you go down, all you have to do is you literally process this thing, you add more scores to it, and then all you have to do is run this API and just say which column you want to predict. It'll use all the remaining columns in the table and automatically predict everything for you, run the model, give you back the confusion matrix, and finally, you can actually deploy this to an endpoint. And so if you're a company that wants to deploy a model to an endpoint, you call this bit of code here, it pushes to the endpoint, and then there's a little bit of code here that will call the endpoint. So here I basically called it with a sample of 5 companies, and it immediately gives me back the credit score for those 5 companies. Okay, so you can deploy all these models automatically, and all that is sort of available. Okay, so the next thing I want to talk about is, can we build better financial models for credit scoring using pre-trained transformers? So many of you have probably worked with transformers like BERT. Transformers are sort of the new age of representing text. And what you do is when you pass a piece of text, maybe it's a word or a sentence or a document to a transformer, it's a giant neural network. BERT, the standard BERT is about 110 million parameters. When you pass this to BERT, it gives you back a vector of size, usually 768 numbers, that represents that text. The most important thing is that collection of numbers puts you at a point in 768 dimensional space. And that point basically is companies that are similar would probably plot in the same region in that dimensional space. So bad companies would be together, good companies would be in a separate space, and you can use this sort of a classification. This is trained on all the text in Wikipedia. So you basically pass through a lot of text in Wikipedia and train these models like GPTs, for example, as well. I'm sort of not getting to the details of this. What we wanted to do was take all of Wikipedia text, book corpus, and a whole bunch of other things, and train a model on 10 years of SEC text as well. So this is like sending your child to school. They learn the language, they learn English or Polish really well, but they don't know finance. And then you pass a whole bunch of finance text through the neural network, and it learns finance as well. So we trained this model on 10 years of SEC text. This is a big effort because we needed 8 GPUs, 8 machines with 8 GPUs each. So there's 64 GPUs. We ran 250,000 training steps. So this is expensive, but once it's done, if you didn't use BERT models, you get about 86% accuracy on news sentiment classification. If you use standard BERT, you get about 92% accuracy. And if you use these financial BERT models, you get up to 95, 96% accuracy. Okay, so it does fairly well on that. And these models are available for deployment. Now you want to explain your predictions. So if the model comes back and says, this is an investment grade company, you want to know which were the most important sentences in the text that led the model to decide that. And so you can take the entire annual report, you can represent it like this, you can highlight the sentences in green that reflect sentences that push the rating up. The sentences in red are the ones that push the rating down. And this is sort of what machine learning can do for you with text. If you fitted a standard logistic regression model for credit ratings, you'd only know which financial ratio was most important in coming up with the rating, and that would be across the data set. Here you can do it for a single application for a credit score, and you can look at which sentences led to good rating, a higher credit rating, and which sentences led to a weaker rating. So explainability is a big new thing in machine learning, and multimodal explainability, like you're seeing over here, is actually sort of the new frontier that we are all trying to work with. The other area of modality is earnings calls. Okay, companies every quarter in the US will announce their earnings, and then they'll do an earnings call for 1 to 2 hours explaining the earnings and taking questions from financial analysts. You can actually score the earnings, the audio of the earnings calls as well as another modality to try and make predictions. So for example, this is the voice signature of the earnings call. And you can see in the beginning, usually the first half of the earnings call is a presentation by a company, and it tends to be green because it's scripted beforehand. And in the second half of the call, the financial analysts start asking the CFO and the CEO a whole bunch of questions, and sometimes it turns red. So this is, I'm not telling you which company this is, but this is the last 5 earnings calls of a company. And you can see it getting progressively more and more red as the economy in the US started getting worse. So the audio emotion scores of people on the earnings calls sort of also got worse. Okay, so you can use audio now as another modality with machine learning to try and predict where the company is going. The large language model revolution really began within the year, and we've seen an entire history from basic transformers in 2018, 2019 to very, very large language models like ChatGPT and Bard and so on and so forth. There's a huge amount of open source activity here that is also taking off. And I believe, at least my prediction is that the open source activity is going to take over everything else, because the which the open source is producing. Every day I get up in the morning, there are 3 more models that the open source community has released that are adaptations of one or the other of these big large language models. So for example, if you take Llama, which is Google's language model, you can ask it questions like, how much money should I have before I can retire? And it gives you perfectly beautiful answers because it's trained on it. You can say, I'm worried about the current state of the market. Any advice? It gives you advice about diversification. Don't put all your eggs in one basket. You can say, I'm 60 years old. I've saved so much. What proportion should I hold? It gives you information there as well. Do you think inflation will ease up? It gives you a whole bunch of reasons for inflation. And so it really does a good job. So something like Lambda, which is language models for dialogue analysis, which is Google's paper from actually a couple of years ago, is underlying this discussion. It's trained on a lot of text, so it's expensive to train, but once these things are trained, they're extremely effective. Okay, so this is where we are probably also going to go with machine learning, and we're going to have multiple modalities added to these language models. So generating text from these models is effective. Morningstar did this about a year and more ago. What they realized very quickly was that they were rating a whole bunch of companies. This is an article from the Financial Times. And instead of rating 6,000 companies with humans, they figured that 5,500 companies can be rated by the machine because there's a long tail of companies that most people do not follow. And then the top 500 companies that are followed can actually be, done by humans. And you can see the storylines for each of these companies generated. It's very hard to say which of these was generated by a human and which by a machine. But it turns out 1, 2, 3, and 5 were generated by human, and 4 and 6 were computer generated. Okay, so this is sort of the new age of replacing financial analysts, credit analysts with generative AI. You can generate code. This is a screenshot of Code Whisperer, which is an open tool now for people to use on Amazon, where I can just give the first few lines and say, function to calculate the monthly payment on a mortgage. It'll actually generate the rest of the code. So lines 1 to 7 were entered by me. Lines 8 through 21 were automatically generated by the machine. It gives me a mortgage calculator without my having to write any code whatsoever. I check it to make sure the answer is correct with a mortgage calculator, and it corresponds perfectly. Emergence is taking place. Okay, so these models have become emergent, and emergence is really, as these models get bigger and bigger, they suddenly become super good at doing the task that they're given. And this is very much like humans. If you send somebody to learn mathematics, they learn different math for a while, and the pieces don't fall together well, but suddenly the human being becomes much, much better at mathematics. And so we are seeing the same thing. As you make these models larger, you suddenly get a big jump on different tasks in the performance of the machine learning model. They're generalist models. The other trend is to make a model not for one particular task like credit rating, but to do multiple different things. So people are now training in finance and economics models that do multiple tasks, from credit scoring to stock prediction to various things, but it's the same neural network that can be used for multiple different tasks. And DeepMind actually put out Gato, which is a general agent that can do multitask machine learning as well. So we're seeing this as a new outcome. The latest class of querying, LangChain, is an open source project. So for example, here I can ask a question, so I've written code to interface with all these large language models. Here I can ask, is Amazon affected by interest rates? Why is it laying off employees? And if you go down into the stack, the human prompt is up here, but as you go further down, you can actually expose the internal system prompts, and you can see the machine actually thinking. It's sending this as a Google search, it's getting back a response, and then it's thinking and saying, that probably explains it, but it doesn't explain something about rising interest rates. So ask another question, sends it out to Google, gets a search result, does some more thinking, and finally gives me back a completely reasonable answer. So you can actually write code now that unravels the thinking of the machine behind sort of the questions that you ask. And this is sort of going to become a big assistant for financial analysts. So what are the things I think going forward will be very, very big developments with multimodal machine learning? So the first is we'll have multimodal, multitask models trained on financial data. So analysts will be looking, for models that will replace them, but will look at images, text, and tabular data. Reinforcement learning has basically been done on numerical data. Now we'll sort of have multimodal reinforcement learning coming in as well. We might have interactive human in the loop with research assistants. I've already shown you some examples of that. We will have time series multimodal machine learning. So we normally do time series modeling in economics with single or multiple time series that are numerical. But I can also take a historical collection of text data. So for example, I can take annual reports over many years and use that as variables to actually create a time trend and do forecasting. So using text for forecasting is going to become important. Forecasts can also be backed up by generative AI, where if I have a forecast that's made by a machine, I can have the machine sort of give me a sort of verbal description of what that forecast is. So I can do scenario generation in words. You already seen examples of image and audio processing and video generation for finance. These models, like these large models, have to continuously be learning. So there's going to be a whole bunch of work done on updating and continuously learning for these models. And then there's a lot of work around responsible AI. These models tend to generate text that's toxic and biased. There's also models that say, things that are completely wrong. So all that, there's a big movement now to make these models responsible and have guardrails on it. And then you can have knowledge organization and knowledge graphs directly from these large language models. So here are some examples of multimodal large language models. Microsoft put out Cosmos 1. Cosmos 1 basically will take images, numbers, text. It's a pretty large model, 1.3 billion parameters. And you can basically train models on multiple modalities to be very big, or you can take single modality large models, like models only for text, only for audio, only for tabular data, and chain them together. And so there are two different ways in which processing of these large language models will take place. One is as a big model that's multimodal, or several unimodal models chained together into a multimodal framework. Just as a coincidence, just 2 days ago, Facebook Meta actually released a 6-way multimodal model called ImageBind, and that looks at text, heat, audio, depth perception, and so on. Okay, and they've sort of got some discussion about the future of multimodal learning. So these models are extremely big. The prediction here is that multimodal learning is going to take off just the way these big language models have taken off, and so we're going to see a lot of extra data from other modalities coming in to make decisions. A lot of governments are using this. So, for example, the Bank of Indonesia is now able to predict housing starts better with geosatellite images than with macroeconomic data that they were doing before. Okay, so multimodality plays out in many different ways. Just to conclude, the very, very large models are in the trillions of parameters. The Beijing Academy of AI, not even recently, almost a year and a half ago, trained a multimodal model that was multimodal on English, Chinese, so it's multilingual, and image mixed with it, and that has about 1.75 trillion parameters. Okay, so this is one of the largest models out there. We are seeing two trends. One is these models get bigger, but the other trend is we are getting these models down to smaller sizes with the same levels of performance because it is extremely expensive to do this. Okay, so quick summary. Machine learning begins with representing data of any mode as a vector or a tensor. We want to bring machines closer to the way humans work with multi-sensory data by making them multimodal. I've shown you a whole bunch of common use cases of multimodal machine learning that work better than unimodal machine learning. The age of transformers has really made things a lot better. And we're going to see the state of the art evolving into multimodal transformers. It's creating a new revolution in distributed computation and hardware as well. So I'm going to stop here and take questions. And hopefully, this gives you some idea of where multimodal machine learning is going in finance and economics.
Nie ma. No to ja teraz zapowiem, że...
Maybe I can start. I'm wondering, do you see any challenges or limitation that you foresee in adoption of generative AI in financial applications?
Right, that's a really, really good question. So let me answer it slightly differently by saying what are the areas in which this will work well and which areas it'll not work well. Okay, so that way you get to both the limitations as well as the benefits of this. So broadly speaking, there are three sort of ways in which generative AI currently will work well. There are applications where generating the text is extremely hard for a human, like writing a 4-page analyst report or writing a legal summary, or writing a legal document. That can sort of take a lot of work by the human, but the machine can generate it really quickly. But it could also generate a whole bunch of rubbish, right? It writes things that are not true and so on. As long as we are replacing hard work by the human, so where generation is hard to do, but verification and correction is easy to do, those applications will become very, very easy and widespread. So for example, if I ask it to generate a financial commentary of the last week's news about a particular company, it can do that really fast, maybe generate 2 pages of text, but you'll find that in that text, it's got some of the numbers wrong, some of the facts are wrong, but within 5-10 minutes, a really good analyst can quickly correct that and make it better. So those are sort of, hard to generate, easy to verify and correct. Those applications are clearly going to be, effective, and we'll see that. Now, the hallucination problem is one of the limitations. Right now, if the thing is going to be completely automated and you want something like a trading algorithm that's going to be working off generative AI predictions, and it's hallucinating, that's going to be hard. That's a clear limitation, because you need very high levels of fault tolerance. And right now, it's not there. Okay, these models are clearly not generating anything accurately to the level that we might want for a financial trading system. So that's one sort of the topic about accuracy versus verification and so on. The second thing is these models are really good because they hallucinate at being creative. So if you want to generate like pictures and drawings, text to image kind of problems, actually hallucination now is a positive thing, right? Because you want it to be creative. But in finance and economics, maybe we don't need that kind of creativity other than the kind of creativity for ideas. So if you say, what kind of debt financing might be interesting for a particular company? Now it'll produce a whole bunch of ideas about, the structure of debt financing that a company might want, which the analyst may not have thought of. And then the analyst can look at it and say, hey, that's a pretty good idea. I would not have thought of that. And maybe, use it to sort of build a structure or debt structure or some sort of deal that they want to do. So that's the second type of application where the hallucination is now working to your advantage rather than to your disadvantage. And the third type of application I think we're going to see a lot of is applications where you're trying to combine the human and the machine together actually are better than just the human or just the machine. And this is usually more like workflow automation problems, where you're trying to automate parts of the process but integrate it in a pipeline where some of the process is human and some of the process is machine learning. So for example, if you want to take a table of data and write a commentary on it, or you want to take a table of data and do performance attribution. So if I have the performance of a hedge fund, all the ratios like a balance sheet or income statement, can I sort of have generative AI write a commentary that can sort of be something that goes into the workflow? Because every hedge fund will be producing a commentary, and that's standard. Now we're already seeing this, by the way.
Yeah, that's already happening. I've seen. Yeah. I'm coming from a venture capital background, and we are analyzing lots of startups. And actually, I was listening to you and thinking about how we could actually use that in the VC world. And maybe within the multimodal analysis, yes, because when you just focus on a pure data, very often, especially in the early stage startups, I think the human touch is so needed that we're going to have perhaps discussion about that later with the rest of colleagues. But I wanted to ask you one more question. So because you're based in California, the capital of venture capital in the world. So have you seen or heard that some VCs are already using AI to to make not only summary of the financial statements, but do they base their investment on AI analysis already?
So the two questions there that you're asking, one is, are VC generating sort of text from financial data that they have for internal sort of analysis and so on? I don't think we're there yet. I haven't seen examples of that over here. What I have seen, of course, are examples where people are using, like the one I showed you, the capital VX model, where we are using text and tabular data to sort of construct probabilities of performance. So that's traditional machine learning on multimodal data versus generative machine learning. But that is very effective. So I'm not involved with that effort, but my two co-authors actually set up a small company after we wrote the paper to actually provide that as a service, to venture capitalists, and it was running. I would have been able to demo it to you because they had put it open, and you could actually have a screen where you typed in any startup and it would give you those probabilities. Then they took it down, so I'm not involved with that right now. But yes, that is something that a lot of VCs were interested in. And there's other work, around similar models as well. So, I mean, multimodal is kind of natural for VCs because they kind of analyze a lot of text with tabular data together, especially because startups and things like that don't have good quality tabular data that's already sort of, historical series of it, and most of it is sort of discussions and documents and things that they provide. So business plans, those sorts of text that can all be processed. So I think what we're gonna see is that people will be fine-tuning models specifically for these use cases. So you might be able to fine-tune a large language model for the semiconductor sector per se. So it becomes really good at analyzing text from semiconductor startups. Then you might have, telecommunication or healthcare or, all these different things. So that trend we're already seeing, that people are going to fine-tune models for very specific industry sectors as well on the language of only those industry sectors, so that it becomes better at those things. Hopefully that was a reasonable. Yeah.
Thank you. That was very interesting.
Yeah.
Sanjiv, may I have a technical request? Could you stop presenting and show your face, because we can't see you at all? It would be just, better for communication to see you. That's a technical request.
Yes, absolutely. There we go.
I could see you.
Oh, thank you. Great.
Yeah. Got it.
May I have a quick question?
Yes.
Maybe it's not related to your presentation, but it's more like an open question about the notion of the ethical AI. I would really love to avoid using this term, this ethical AI, because it's more about creating and implementing AI in an ethical way. But the question is how, or if we, how can we ensure that, for example, large language models are in line with the expectations, let's say, or guidelines or whatever, or recommendations when it comes to the ethical AI or something like that. We have this discussion and also some legislative proposals here in the European Union, for example, AI Act, which may impose additional requirements for such models, for example, for explainability and okay, so that's my question actually. So, are we able to do that, or maybe it's just something that is not possible to be done? Okay. Tak, to możemy odpowiedzieć sobie.
Too hard.
He's back.
Sorry, the connection dropped. I did get a question. The question was about ethical AI, right? So, and how to think about it in the context of large language models. Am I right? That was sort of the question. Can you hear me, Eliza? Yeah. Okay, great. So let me say a couple of things about this. I think that's a great question, because I think there's a lot of discussion about responsible AI and ethical AI, and what should our expectations be around this. There are a few problems that I think relate to what you're asking about. The first is ethics has always been about bias and toxicity, and these are two kind of separate things. One is that the large language models can learn biases, that are embedded in language. So traditionally, a lot of text, for example, the standard example is professions, right? They have certain professions aligned with women and certain professions aligned with men. And so if you ask something, it'll automatically assume, that all engineers are men and all nurses are women and things of that sort. And that's clearly a biased view. And the writing then reflects that biased view, which is a bad thing. Okay, so we do know how to sort of handle some of these things. There's a literature now on removing this kind of bias, when the text is generated by the large language model. But there's so many different types of this bias that this sort of starts getting done on a case-by-case basis. The other kind of ethical problem is that the language model learns from all the text on the internet, a lot of which is toxic. And so it starts sort of emitting toxic language. And over the last 3-4 years, there's been a lot of work in machine learning on detecting toxic text and sort of, canceling it out and not producing it. So that is a pretty well-solved problem. So toxicity actually is a slightly easier problem than the bias problem, and that's also been handled. The third is the large language model going to be allowed to answer all kinds of questions? So can you answer questions about financial advice, personal advice? Is it allowed to be a therapist? And if you've noticed over time, ChatGPT and Bard and all these open models, as you're playing with them, 2 months ago, I could ask it for financial advice and it would give me a whole bunch of 2 pages of financial advice. And now if you go and ask it, it'll say, sorry, I can't give you financial advice, and you'll have to write your own code to actually, do some of that through an API rather than through sort of a chat interface. So there are various guardrails now that are being put also to manage sort of the ethical use of AI. Another type of problem that we also have that is ethical is copyright. Because these models are trained on a whole bunch of stuff, and for example, OpenAI and other companies have been extremely careful actually in trying to train models on text that is not copyrighted or images that are not copyrighted, but some of it will leak in. There's no way you can prevent it. And then if you generate text, so I'm an academic, I don't want to generate text and put it into my papers because I might be plagiarizing somebody. And we know that your reputation is all you have as an academic, and if you go plagiarize something in your card, it's a big problem, and you actually don't want to do that. So I'm very scared to use these things because plagiarism is an ethical problem, and I don't even want to go anywhere near that problem actually happening. So copyright is also another ethical issue. The other area of ethics that people talk about is labor market ethics, right? That what is it doing to people's jobs, and are we okay with that as a society? In allowing that to happen. And so that's sort of another type of ethics, which is around, employment, society, and the human condition. And finally, there's a whole bunch of things around, what does it do to society and how it changes interactions in society, and are we going to have ethical problems from there? Finally, there's the big ethical problem, which is, people like Elon Musk talk about, and Gary Marcus and Max Tegmark at MIT, which is, are they going to destroy humans? Is it one day going to come and kill humans? And this kind of crazy scenarios that will happen. So Jeff Hinton, for example, who ran AI at Google, has just left because he's now becoming very concerned. So I think a lot of us I'm in the camp where, look, I don't think this is going to kill all the humans. Okay, that seems pretty far-fetched. But over the last 2 weeks, I've sort of gotten more on the camp where now you can build software agents using these large language models that autonomously do a whole bunch of stuff. So if you just Google LLM agents, you'll find a whole bunch of tools that anybody with very little coding experience can actually build agents to trade, to do transactions, to do all kinds of things based on large language models, generate text in any way you want. And what happens if we have an entire ecosystem of people writing agents? These agents start interacting with each other and generating emergent behavior that we cannot understand, and that starts bringing down financial markets and doing other things. Right now, the trading agents have been built by very large companies that are regulated, but now we can have agents in the economic system that anybody can build that uses these large language models to do all sorts of financial activity. And you can imagine this being a big risk. And this is the risk I actually worry about more than AI is killing humanity or something of that sort. So I think these are sort of different dimensions of ethical AI that have suddenly become much more salient because these large language models have become so ubiquitous, so easy to use with a lot of the software tooling that the open source community is producing. You cannot regulate the open source community very well. Okay, so they're going to keep producing this stuff because it's cool, it's exciting, but it's generating the ability for a lot of people to do crazy stuff that has dangerous implications for the financial and social ecosystem. And obviously, that's an ethical problem.
Thank you so much.
Thank you. Are there any other questions, Professor Das?
I have a question, actually. How do you believe we can control bias in unstructured data? Because we can control, if we are talking about numerical tabular data, we have clear target value of the model, then you have very clear measures. What is the difference? What is the bias?
Right.
And if we go to the text, we are talking about consistency of the text, but we're also talking about generation of new connections. So how can you be sure there is bias or there is no bias if we go to unstructured information?
Yes, absolutely. You're completely right that it is much higher to detect, measure, and mitigate bias in text than in tabular data. So there's two directions in which this is going. One direction is pre-processing the data for bias in the first place. So when you train the model, the text you feed the model can be pre-processed or curated for toxicity and bias. So what you do is you can write tools that will remove toxic text. Okay, that's easy to do. Then you can train embeddings that will actually, so once you have an embedding for text, let's say you take all the sentences and you produce a vector embedding for each sentence, you can then look at where these embeddings plot in high dimensional space. And if they plot in areas where the gender, you have to choose some dimension of bias, whether you're looking at gender bias or race bias or age bias, things of that sort. Then you can look at regions of the text that relate to the concepts of gender and age and look and see if the embeddings cluster in two different ways, so that there's a group that sort of tends to be over prominent in that cluster. There are papers on this. So if you Google papers on word embeddings for detecting textual bias, you can take a look at that literature and work with it. So pre-curation or pre-processing of the bias out of the text is one way to mitigate it. Now, let's say you don't do that and you train models to do classification with tests or to generate text based on a language model on data that was not pre-processed or pre-curated. Then post-processing, you can do exactly the same thing. If you generated text, you can sort of look at the post-processed text embeddings and see whether they, populate regions of in the embedding space where there might be gender bias, age bias, but you have to sort of have the dimension of bias somewhere in mind, which makes this problem harder. And then if it's just predicting, should somebody get a loan or not get a loan, you can clearly use traditional tools to detect whether the model's predictions itself are biased. For that, we have a whole bunch of different metrics. In fact, I have a couple of papers published on this as well. We can have metrics that look at, is there demographic parity in the predictions from these models? Is there the true positive rates across two classes, let's say men and women, are the same? Is the false positive rates the same? So there's a bunch of these different types of metrics. And depending on the value system and the society you're in, you might choose one metric over another. Okay, so yes, there is a lot of active work going on managing text bias or just bias in unstructured data as well. In the other modalities like video and audio, you also have this problem. And there you also have issues of privacy. And this is another ethical issue, by the way, that comes up with large language models because they know a lot about things that might actually even reveal privacy sort of violations. So, for example, if you go to a large language model and you ask it to give me a description of Sanjiv's research or something, it might pull up things that were somewhere in the record that actually should have been privacy controlled, but didn't sort of get correct PII treatment in the data set. And those problems are also hard to detect. Can I use voice to identify who's identify people, or video to identify people later? So I collect video of you, and people can, law enforcement can use it, and so on and so forth. So in the US, this is a sensitive issue, and there are laws to protect it, and so on and so forth. So yes, so there's privacy issues, there's bias issues, there's toxicity issues, but the broad answer is there's pre-processing ways to handle this, and there's post-processing ways to handle this. And if you're just talking of unstructured text, there is a reasonable literature now that you can kind of go to and look at it for exactly this problem.
Okay, thank you. Do we have time for one more question?
Maybe last question, okay? Can we ask you one more question?
Sure. So I have a question. Actually, I would like to ask you for a comment. Like you showed a lot of very interesting tools, shiny tools that can be used, and there is a number of them, and the number is growing really quickly. But yes. What do you think? Should we as community maybe talk more about testing of these tools, validation of these tools, checking whether they are safe or not? Because many of these tools, we know that they are biased. So maybe we should not use them until they will be actually verified. I kind of like the approach from OpenAI because they said a little about model, but a lot about validation. And then so what is your opinion? Maybe instead of saying about number of models, maybe we should actually talk about how we should test them, put them into a deployment in a safe way.
Right. So for discriminative machine learning, we've been having a lot of metrics for like all the accuracy metrics, F1 scores. So if you're just doing classification and things like that, we have a lot of metrics. We also have metrics in that world for bias. So if you went to Amazon, for example, I was working, build SageMaker Clarify. We have 20 metrics for data set bias. We have 20 metrics for prediction bias. So there's a lot of that. Now with generative AI, sorry, go ahead.
Yeah, because performance is not enough. We have a lot of examples that models were performing well on historical data, but then after deployment, after 1-2 years, they are not working correctly. So the problem is that we need more than just performance metrics. Like I think that we need to add really good tools for explainability or other ways to validate models.
All right, I'm back. Sorry, the connection was off. Yeah. Go ahead. Can you ask me that very quickly again?
So the question is like, I think that performance is not enough. Like we have examples in literature that great models achieve great performance, but then after a year or 2 years, actually the performance degrades.
Yes.
So should we have more tools, different approaches, how to make sure that these models are really safe?
Yeah, so I think we are seeing a growing number of tools for generative AI coming, and it's called, so for example, like you mentioned, OpenAI, they have a whole subsystem called evals. So they have a GitHub repo called evals where you can use what they have for evaluation. So there are many, many metrics there that you can think of. One is it generating good answers? Is there high veracity? So think about if, let's say you have a generative AI that generates an image of a cat, and you say generate an image of a cat with white fur or something like that. Now, how do I check whether it really did the answer correctly, did the job correctly or not? One way is to have another model that detects cats and call that model and say, did it actually detect, was it generating a cat or did it generate a dog by mistake? So you have another model that supervises this model. We are seeing a lot of that happening. When it generates an answer, you can send it to another large language model and say, do you like this answer? Is it a good answer or a bad answer? And so on and so forth. So these are sort of in runtime, you can do things to assess how good they are. There's a whole bunch of other ways to sort of assess models. People are using the perplexity metric to see whether the quality of the text from a particular prompt. So you can compare the prompt text to the output text, the response text, and do some sort of comparison between the two to see whether the answer was good or bad. Because it could be something that just generates a lot of nonsense text, and that will be picked up by the perplexity score. But it could also, so you want some relationship to the prompt, but you don't want it to be just repeating the question, right? Kind of response. So there's a whole bunch of testing like this that's already going on. So we're going to see, I guess, maybe over the next 3 to 6 months, a whole bunch of new metrics that come out for evaluating whether the text was generated accurately, whether it was sufficiently rich, whether it was different enough from the question, whether the perplexity score was high or low, whether it was toxic, so these are sort of all the dimensions. Now, why is this important? I think what you're asking is a super important question, because if you have a growing number of models to choose from, each use case might be better suited to one model versus another large language model. So for example, if I want to use GPT-4, I might get a particular kind of response. Then I go and use, maybe Bloom, which is a completely open source model out of France. And I want to know whether the responses, which of this is generally giving me better responses for my particular use case. Again, I need sort of these testing things on both the models. So I need some way to evaluate which of these models is better. So we are seeing a bunch of these. I kind of mentioned some of these metrics. There's a bunch of evaluation packages on Hugging Face and OpenAI, and most of the other big tech companies have these. So you probably see a lot of these tools now for assessing the quality of outputs from a large language model. Another way to assess it is, like I showed you, it gives you the internal reasoning for it. And, that's sort of instance by instance reasoning, which is really a test. do I agree with the reasoning it went through and gave me the final answer? So you can print it out and take a look as well. So I know it's not a complete answer. This is a very new space. So your question is spot on. I think, it's something we're going to see a lot of cool stuff coming out, in the next few months.
Thank you.
Thank you. Thank you very much. Thank you for the lecture. Thank you for answering the questions. Sure. Yeah. I think it's all for this official part. Now we will start our panel discussion. So once again, thank you very much for giving very interesting lecture. I hope there will be some discussion open thanks to your presentation. And I hope maybe in future we can meet again at Warsaw School of Economics.
Thank you so much for inviting me to give the talk, and I'm really honored to be here.
Our pleasure.
Our pleasure.
Thank you.
Thank you.
Lisa, do you want me to stay on, or you're going to do everything in Polish now? So.
Yeah, I have to. I need to stay with them in Polish. I will try to find you on LinkedIn, and maybe like that we can be in contact. Yeah.
Okay. Thank you very much.
Thank
Bye,
you.
everybody.
Thank you. Bye. Koniec. Teraz. Będzie w języku polskim już i będzie dotyczyła głównie problemu poruszonego w prezentacji profesora Dasa. Więc tak może na wstępie to od razu, jeżeli się jakieś pojawiły pytania, na pewno się pojawiły w trakcie prezentacji, to bardzo proszę, teraz jest taka chwila, żeby od razu z nimi wystartować. Może Pani jako kobieta będzie miała pierwszeństwo.
Ale do kogo mam zadawać te pytania?
Nie, jakiś problem na przykład do dyskusji, coś może się Pani nasunęło podczas prezentacji profesora Dasa i Pani uważa, że ten problem warto by było poruszyć, przedyskutować.
No ja po pierwsze dziękuję bardzo za zaproszenie. Nie wiem, czy moi współdyskutanci mnie znają. Ja nie mam pewnie takiego ekonomicznego, nie jestem ekonomicką, nie mam takiego doświadczenia jak Państwo, więc pewnie na takim naukowym poziomie macie Państwo o wiele większą wiedzę niż ja. Ja patrzę z takiego punktu widzenia praktycznego zastosowania tych multimodalnych modeli, o którym mówił Pan profesor w świecie biznesowym, czyli w tym działce, w której ja jestem, a mianowicie w świecie venture capital. No i myślę, że jednak jeszcze jest ogromna, długa droga do tego, żeby to się spopularyzowało i szczególnie to jest trochę to, co mówiłam, pierwsze, co mi przyszło do głowy, jak słucham tej prezentacji w kontekście podejmowania decyzji inwestycyjnych. To może w przyszłości, oprócz takich twardych danych, które dostarczają nam startupy, będzie można dołączyć, nie wiem, jakieś prezentacje wideo i będzie można przeanalizować emocje i to, jak ktoś się prezentuje, jakiś potencjał leadershipowy, jaki dany zespół sobą prezentuje, bo szczególnie na tym wczesnym etapie rozwoju startupu, rzeczywiście te decyzje podejmuje się na zasadzie nie tylko twardych liczb, ale też takich osobowościowych założycieli. My bardzo często patrzymy, czy charakter tego założyciela startupu jest na tyle twardy, że on będzie na tyle wytrwały, żeby doprowadzić projekt do końca. I tutaj pewnie ciężko to w jakiś sposób skwantyfikować i nie jestem ciekawa, co Państwo o tym myślą. Czy wy widzicie takie zastosowanie w tym świecie venture capital? Może czegoś, czego ja nie widzę, może już znacie?
Bardzo proszę, Pan Profesor Biecek bardzo chętnie zajmie się tym tematem.
Chętnie odniosę się do tego wątku z charakterem. Ale powiem najpierw takie sobie krótkie wprowadzenie, dlaczego się odniosę tak, jak się odniosę. Ja jestem inżynierem z wykształcenia i bardzo chciałbym, żeby narzędzia, które powstają, które tworzą, żeby były bezpieczne. Tak, bo jednak te mosty powinny funkcjonować, budynki powinny stać i tak dalej. Więc mamy nowe technologie, takie jak AI. Pytanie, do jakich innowacji nas doprowadzą. Nie chcielibyśmy pewnie powtórzyć błędów młodości, np. instrumentów pochodnych, które generowały masywne ryzyko, którym nie zarządzano właściwie, tak nie było ono śledzone. A wydaje mi się, że jest rzeczywiste ryzyko, że w tej chwili te modele wygenerują nam ryzyko, którym nie potrafimy jeszcze zarządzać. To mamy eksperta, więc mam nadzieję, że ten temat będzie dalej pociągnięty. Ale mnie w tej prezentacji trochę zabrakło takiego jednak skupienia na walidacji. A dlaczego do tego charakteru chcę się odnieść? Bo historycznie mamy wiele przykładów rozwiązań stosowanych w dużych firmach, które dyskryminowały z uwagi na różne cechy, na przykład płci lub rasy. Takim jednym z ciekawszych, dla mnie przynajmniej w tej dziedzinie, przykładów jest system rozwijany przez Amazon. On nie został wdrożony, ale ten system, znaleziono w nim wiele zaszytych biasów, skrzywień w stosunku do płci, bardzo subtelnych, gdzie oczywiście nie było tak, że ktoś za płeć dawał mniej punktów, ale system nauczył się, że mężczyźni używają trochę innego słownictwa, częściej używają słowa takiego jak executed i za to dawał punkty. Tak? Lub też nauczył się wykrywać żeńskie licea i za nie karać. Więc świetnie mieć narzędzie, które oceni charakter prawda, CEO, jakichś innych founderów. W Unii Europejskiej to będzie pewnie zabronione, bo AI Act zabrania nam scoringu personalnego, przynajmniej oficjalnie, ale nawet gdyby było dozwolone, wydaje mi się, że jest pewne ryzyko, że te narzędzia bez odpowiedniej weryfikacji mogą nam wygenerować olbrzymie ryzyko.
Ja się zgadzam, absolutnie. W takim sensie, że jestem też bardzo sceptyczna.
Chciałbym myśleć o tym realistyczna, ale znaczy myślę, że są olbrzymie nadzieje, ale trzeba też widzieć drugą stronę, tak? Trzeba też widzieć ryzyko.
Ja myślę, że zastosowań AI będzie bardzo wiele i zarówno przykłady podane przez Panią, taka analiza psychologiczna, analiza obrazów, jakiś autotrading, jakieś doradztwo strategiczne, dokumenty. To jest przestrzeń, gdzie mogą być rozwiązania. Tak, i AI może nam dostarczyć technologii, która coś takiego zrobi. Ale pytanie, czy my tego chcemy, kiedy możemy tego chcieć i jakie warunki powinny spełniać te modele, żebyśmy mogli je tam zastosować, to jest chyba tutaj pierwsza ta granica, żebyśmy podzielili obszary zastosowań i wiedzieli, gdzie chcemy po prostu jak najbardziej trafnego modelu i nieważne, co jest w środku, a gdzie mamy pewne warunki do spełnienia. I jakby ten profil psychologiczny może być uchwycony, tylko pytanie, czy my chcemy oddać tej czarnej skrzynce ocenę psychologiczną i potem już tylko mieć rekomendacje, czy my chcemy rozumieć, jaka to jest ocena psychologiczna i to chcemy rozumieć do głębi. Nie dam jakieś pojedyncze spojrzenia, że raczej tu w prawo, a raczej tu w lewo, tylko naprawdę, żebyśmy rozumieli, czy introwertyków niżej czy wyżej oceniamy, a ekstrawertyków to inaczej, a osoby agresywne to my tutaj deprecjonujemy, czy im dajemy dodatkowe punkty. To my powinniśmy dobrze rozumieć. I teraz w zależności od aplikacji te wymagania wobec AI będą inne i tam, gdzie tych wymagań nie ma, to powinny być tak naprawdę bardzo szybko wdrożenia. Korzystajmy z tego, korzystajmy z tej efektywności. A tam, gdzie rzeczywiście to ryzyko obciążenia, wykluczenia jakichś grup społecznych, zrobienia sobie krzywdy, nawet bezpośrednio, czasami nawet o tym nie wiedząc, no to jeżeli widzimy takie ryzyko, no to rzeczywiście akty typu AI Act są potrzebne. No i są potrzebne oczywiście, żeby były wypracowane z nami praktykami, bo to chyba też nie tylko o to chodzi tak z punktu widzenia konsumenckiego, żeby coś zablokować i tak tylko werbalnie powiedzieć, że to będzie teraz zabezpieczone, bo to się nie dzieje. Bo albo wylejemy dziecko z kąpielą i po prostu założymy kawał biznesu, albo ten biznes będzie coś tam robić pod stołem i tak będzie realizować swoje zadania. Więc jakby przy formułowaniu takich regulacji, one są niezbędne w tych wrażliwych obszarach, ale to powinniśmy sięgać no nie tylko do tej wiedzy prawnej, nie tylko do oczekiwań konsumenckich, ale również do wiedzy dziedzinowej, tak? Bo to ona tworzy ten cały rynek, który aktualnie funkcjonuje. Także ja myślę, że takie narzędzie będzie, że Pani je dostanie, tylko że my po prostu musimy obudować te dzisiejsze fajne czaty, large language models, no właśnie o te dodatkowe toole, które pan profesor nam obiecywał, no ale jak je zobaczymy jak one będą pracowały, te mechaniki do walidacji, czy rzeczywiście da się je zasilić, bo ja też tak rozumiem, że tak jak mówimy tutaj o badaniu biasu w tekstach, badanie biasu versus płeć, versus religia, versus narodowość, to teraz jest pytanie, czy my to rzeczywiście możemy zrobić dogłębnie, bo my musimy w tym momencie zebrać dane o płci, religii, narodowości, musimy je przetworzyć, musimy wytworzyć modele. To teraz my takich danych dzisiaj nie zbieramy, bo nie możemy, to de facto jak wygląda ta weryfikacja. Więc jakby otwiera się szereg pytań i myślę, że my tak powinniśmy patrzeć na AI, to jest jakby ten nowy dynamit, skorzystajmy z niego, ale wkładajmy go tam, gdzie wiemy, jak on wybuchnie, a tam, gdzie nie wiemy, no to szukajmy tych bezpieczników. Oprócz modelu, tam warstwa walidacji, jak go oglądać. Tak to widzę z perspektywy ryzyka.
Nie, ja się bardzo cieszę, bo dokładnie to chciałem usłyszeć. Znaczy też wierzę w potencjał i rzeczywiście ważne jest, żeby określić, gdzie mamy obszary dużego ryzyka, a gdzie jednak możemy stosować bez większego ryzyka rozwiązania. Chociaż mam wrażenie, że jeszcze nie skonsumowaliśmy modeli, które są prostsze niż te, które były prezentowane i najpierw musimy to odrobić lekcję, żeby nauczyć się wykorzystywać nawet płytkie sieci lasy losowe, zanim sięgniemy już po te bardzo zaawansowane, wielomodalne systemy. Bo ten przeskok być może nie jest możliwy, być może najpierw trzeba jednak wdrożyć rzeczy, które są jeszcze nieskonsumowane.
Przez ten przeskok, bo to można zmierzyć. Jaki jest ten value added z dołożenia niesamowitej złożoności w modelu, a ile ładujemy ryzyka przy okazji, tak? Jeżeli mamy właśnie w miarę płytki model, który możemy zdiagnozować, albo wręcz możemy explicitnie interpretować parametry, versus jaki jest increase tej wartości dodanej, jeśli ona jest ok, jeśli to jest zmiana fundamentalna i bezpieczna, to idźmy tam, a jeśli nie, no to jest rzeczywiście przekombinowanie, tak? To jest rzeczywiście nie za szybko. Bardzo, bardzo fajna uwaga.
Czy jest sens iść takie sophisticated, takie metody, czy może problem leży gdzie indziej, na przykład w jakości danych, tak? Może się okazać, że jakość danych jest dużo istotniejsza niż te takie super wymyślne i skomplikowane metody.
To jest trochę nasze doświadczenie, nasze jako sektora bankowego i modeli ryzyka, gdzie my jakby od początku, tak, najpierw myśleliśmy przede wszystkim o efektywności, o trafności modeli, ale z czasem doszliśmy do tego, że stabilność, zrozumienie tego, co jest w środku, wyjaśnialność dla konsumenta, wyjaśnialność również dla nas, czy to jest rzeczywiście zgodne z polityką banku i z planami długoterminowymi. Bez rozumienia tego, co jest w środku, no niestety takie modele stwarzają ryzyka, których nie chcemy, nie potrzebujemy. I w związku z tym w bankowości w niektórych obszarach my nie dążymy do maksymalizacji efektywności, bo właśnie te pozostałe wymiary zarządzania ryzykiem modeli są dla nas dużo bardziej wartościowe i ważniejsze z punktu widzenia stabilności całego biznesu, zastosowania. Więc jakby ta ścieżka, to może dlatego ja tą analogię widzę generalnie dla sztucznej inteligencji, żebyśmy wiedzieli co do czego, jakie kryteria potrzebujemy i potem stosownie możemy albo wyciskać te modele, albo trzeba je po prostu dobrze rozumieć.
Tak.
Jestem ciekaw bardzo perspektywy VC. Jaka jest perspektywa na wspieranie rozwiązań rodzimych, co by to znaczyło? Jak to wygląda? Tak, tutaj jest na horyzoncie szansa dużego programu, który by zainicjował setkę nowych unicornów w Polsce w obszarze AI, czy to raczej oczy VC są skupione na zachód, wschód, nie wiem, północ, południe?
Bo pewnie myśli Pan o tym, czy powstanie jakiś rządowy program wspierania sztucznej inteligencji, tak?
Nie, rządowy nawet istnieje, ale myślałem bardziej o prywatnych pieniądzach.
To my jako fundusz funduszy finansujemy fundusze inwestycyjne i dosyć mocno trzymamy się takiej zasady, że to fundusze inwestycyjne same decydują, w kogo będą inwestować. One pewnie wybiorą jakby zespoły, w które będą chcieli inwestować, które przyniosą im jak największe zyski. I teraz rzeczywiście, obserwując ostatnie parę miesięcy, to jest tak zwany, jest taka moda na te startupy z branży AI-owej i nie ma tu żadnych ograniczeń co do miejsca pochodzenia tych pomysłów w tak zwanym obszarze generative AI. Więc czy to będą polskie startupy, czy zagraniczne, nie ma żadnych ograniczeń. Raczej motorem tutaj jest zwrot z inwestycji, więc no pytanie jest, jak dużo takich startupów powstaje. Wiem, że są inicjatywy, które zresztą nawet ostatnio polski zespół podpisał kontrakt, co prawda z Arabią Saudyjską, 30-milionowy na stworzenie serii hackathonów, czyli takich maratonów programistycznych, podczas których na różnych językach, nie tylko OpenAI-owych, buduje się prototypy aplikacji, które potem są akcelerowane, czyli przechodzą przez takie programy szkoleniowe, a następnie inwestowane w funduszy Saudii Arabii. Więc widać, że niektóre rządy jakby w ten sposób wspierają i tam chcą przekierować swoje inwestycje. My nie możemy naszym funduszom, które mamy w naszej tak zwanej stajni PFR Ventures, powiedzieć, co one mają inwestować, ale na pewno to wszystko, co jest .ai, jest bardzo popularne i teraz wyceny startupów, które są oparte o sztuczną inteligencję, bardzo mocno poszpowały w górę.
A jak tak byśmy się przyjrzeli na polskie podwórko i porównali tak na tle Europy, no bo świata może za dużo, przynajmniej Europy. Jak wygląda tak zastosowanie i w ogóle zastosowanie, używanie tych metod AI, ML w fintechach, w instytucjach finansowych? Tak jak już Państwo obserwujecie, na pewno jest doświadczenie, widzicie to już. Co możecie powiedzieć? Jak wyglądamy na tle Europy?
Według mojej wiedzy to akurat w Polsce to środowisko bardzo aktywnie się rozwija i te rozwiązania, które są dostarczane do sektora finansowego, one są wdrażane i nasze banki są nowoczesne. Tak jakby to trochę mamy echo, no, można powiedzieć, późnego wejścia w kapitalizm, ale to znaczy, że mieliśmy przemianę, stawianie systemów w latach 90. bez biasu, bez długiej historii. No i efekt jest taki, że ta absorpcja nowinek jest stosunkowo szybka. I tak samo na poziomie banków, jak i na poziomie firm pożyczkowych, które również u nas bardzo aktywnie szukają rozwiązań. Tylko teraz pytanie, gdzie je można rzeczywiście bezpiecznie wprowadzić, jak to w praktyce wygląda? No to są obszary, gdzie no to już wszyscy słyszymy, tam no akurat słyszeliśmy na pewno, fotowoltaika dzwoniła do każdego z nas, ale oprócz tej fotowoltaiki to tak naprawdę systemy sprzedażowe, systemy obsługujące klientów, reklamacyjne w bardzo wielu instytucjach w tej chwili już są zautomatyzowane i rzeczywiście tam pod spodem siedzą automaty, a dotrzemy do konsultanta, jak naprawdę się uprzemy, że on jest potrzebny, a z drugiej strony dzięki temu dużo krócej czekamy w kolejce i to ja przez długi czas no, bardzo chciałem z ludźmi rozmawiać i miałem osobiście taką potrzebę, że nie chcę z tym automatem, ale jak już swoje wyczekałem w kolejkach i potem się okazało, że z automatem jednak załatwię to szybko, no to jednak ta skuteczność mi przekonało, tak, to rzeczywiście ma sens. Więc takie zastosowania w obsłudze klientów rzeczywiście są bardzo szerokie, to się bardzo dynamicznie rozwija. Podobnie w coraz bardziej istotnych elementach bankowości i obsługi kredytowej coraz głębiej AI wchodzi, na przykład na etapie weryfikacji klientów, coraz więcej mamy automatycznych systemów, coraz więcej mamy więcej systemów też takich automatycznej weryfikacji, na przykład zdjęcia twarzy, tak jak na początku było oczekiwanie, że klient osobiście przyjdzie do oddziału, tak, i tam zweryfikuje go konsultant. No potem pojawiły się systemy, kiedy weryfikacja była zdalna, ale wciąż konsultant siedział po drugiej stronie kamery komputera i tylko prosił, odwróć się w prawo, odwróć się w lewo, popatrz do góry, powiedz 3 słowa i konsultant patrzył, czy rzeczywiście to się dzieje. Dzisiaj takie porównania robią już automaty. I dzisiaj już automaty robią taką weryfikację przy zakładaniu konta, więc jakby to już jest rzeczywistość, tak się dzieje. No i błędów jest powiedzmy na tyle mało, na tyle jest to skuteczne, że takie rozwiązania wciąż funkcjonują. Miejsce, gdzie machine learning jest bardzo ostrożnie wprowadzany i z dużą kontrolą, to jest ocena ryzyka kredytowego i sama decyzja kredytowa, bo to jest ta przestrzeń bardzo, bardzo wrażliwa. Chcielibyśmy, żeby nas oceniono rzetelnie, chcielibyśmy, żeby wszystkie informacje były wzięte pod uwagę, chcielibyśmy, żeby tam nie było, żebyśmy nie byli tym jednym procencikiem, na którym się akurat automat teoretycznie pomylił. Chociaż w praktyce to jest tak, że automaty mniej błędów popełniają, więc jakby to trochę takie jest teoretyczne oczekiwanie. To jest taka fobia, która nie do końca jest uzasadniona, ale realnie banki bardzo ostrożnie podchodzą, jeżeli chodzi o budowanie tych automatów decyzyjnych czy modeli, które oceniają klienta, bo tutaj mamy wymaganie i co do tego, że same banki powinny rozumieć, jak modele funkcjonują, każdy parametr, czy on działa we właściwą stronę z punktu widzenia historii kredytowej, opóźnień klienta, jego doświadczenia, czy rzeczywiście za to, co powinien klient dostawać nagrodę, dostaje nagrodę, a za to, co powinien dostawać karę, to dostaje karę. To takie oczekiwanie wobec banków jest i banki to rozumieją i banki to stosują i w związku z tym machine learning, jeśli jest stosowany, to jest stosowany jedynie w niektórych elementach takiego procesu decyzyjnego, żeby przygotować ciekawe cechy, żeby zbudować jakiś taki idealny model, zobaczyć, jaki jest taki minimalny poziom błędów, jaki można osiągnąć, czyli takie benchmarkowe podejście, ale finalny model musi być dobrze zrozumiany przez samych bankowców, również po to, żeby potem być w stanie odpowiedzieć na reklamację, bo klient przychodzi, nie dostałem kredytu, dlaczego nie dostałem kredytu? Co się stało? Czy mogę coś z tym zrobić? Czy rzeczywiście moja sytuacja jest tak ryzykowna, że to jest uzasadniona decyzja? Więc jakby takie pytania się zdarzają. Jeżeli za bardzo pojedziemy w te czarne skrzynki, no to niestety na takie pytania nie odpowiemy. I dlatego tu postępujemy jeszcze jako bankowość ostrożnie i te zastosowania machine learningowe w tym samym procesie decyzyjnym tak wrażliwym no, są jeszcze ograniczone.
Od strony popytu już nic więcej nie dodam, ale od strony podaży mogę powiedzieć, że jako nauczyciel akademicki podawałem programy kształcenia na różnych uczelniach w Europie i wygląda na to, że mamy bardzo duży potencjał kapitał ludzki. Kapitał ludzki, czyli bardzo wiele osób po naszych uczelniach rzeczywiście ma dobrą znajomość zarówno takich prostych algorytmów uczenia maszynowego, jak i tych zaawansowanych, najbardziej nowoczesnych modeli generatywnych, technik wyjaśnialności, więc no, mamy potencjał też, żeby budować to rozwiązanie.
A jak pani dyrektor to widzi ze swojej strony?
Tak, dla mnie te rozwiązania w branży venture capital mogą wspierać wiele aspektów inwestycji, prawda? Od przeszukiwania i analizy potencjalnych startupów, bo rzeczywiście ta generatywna sztuczna inteligencja może przeszukiwać ogromnej liczby potencjalnych startupów, może nie jak rozmawialiśmy na początku, analizując ich profile psychologiczne founderów, ale może dostarczać informacje o trendach w danej branży, identyfikować startupy o wysokim potencjale wzrostu, prawda? I wyszukiwać tych zgodności z preferencjami inwestora. Może też prognozować potencjał wzrostu takiego startupu, przeprowadzając różne analizy finansowe, danych finansowych, analizę trendów rynkowych, różnych innych takich czynników, które mogłyby tworzyć jakieś predykcje dotyczące potencjału sukcesu takiego startupu. Zakładam też, że można by było tworzyć modele wyceny takich startupów, prawda? Tworząc różne takie modele, które pomogłyby w przyszłości określić wartość firmy w różnych scenariuszach. Co do tego, czy to się już dzieje, no ja nie widziałam jeszcze w funduszach, żeby prowadziły zautomatyzowane procesy inwestycyjne. Raczej to jest ten etap, o którym mówił profesor trzeci, czyli łączenie tego czynnika ludzkiego z wspomaganiem się właśnie analizą danych, która jest jakimś takim uzupełnieniem przy podejmowaniu decyzji inwestycyjnych i tworzeniem jakiejś takiej synergii.
Super. Myślę, że na ten temat to można mówić i mówić. Tutaj, tak jak pan dyrektor powiedział, jest bardzo ciekawe to zastosowanie ML przy takich ogólnych kwestiach typu w tych chatbotach, tak, że przeskakujemy do kolejki, czy w takich ogólnych modelach benchmarkingowych. Uważam, że to jest bardzo fajne, ale na przykład przy fraudach to wydaje się, że jednak te modele ML trochę lepiej działają, ale to głównie dlatego, że mają tą możliwość łączenia danych z różnych źródeł, prawda? I to, co zwykły analityk tego nie wychwyci, to połączyć na przykład dane bankowe z danymi, o ile można, takimi zewnętrznymi, z sieci społecznych, no to już może nam naprawdę pomóc w wyszukiwaniu takich zdarzeń, tak, fraudowych. Więc tutaj jest jeszcze duży potencjał, myślę.
Myślę, że w każdym zastosowaniu modele ML ze względu na swoją elastyczną konstrukcję, z punktu widzenia efektywności, one mogą i jakby jak patrzymy tylko na parametry, będą działać lepiej niż modele klasyczne wyjaśnialne. No po prostu taka jest natura. To tak jak, nie wiem, parabola lepiej się dopasuje do prostych niż linia prosta, tak? Do punktów niż linia prosta. Po prostu ma większą elastyczność, więc jakby modele ML z tego punktu widzenia tą przewagę mają daną na starcie, że one lepiej wyeksplorują dane, one z większą dokładnością się dopasują. Tylko pytanie, czy to jest nasz jedyny cel w danym zastosowaniu. Jeżeli to jest nasz jedyny cel, no to w takim razie droga otwarta i z tymi modelami możemy startować. Jeżeli mamy jeszcze inne kryteria, no to wtedy wchodzą w grę dyskusje o innego rodzaju modelach albo o tym całym bukiecie dodatkowych narzędzi, explainable AI, żeby trochę ujarzmić, tak? Nie tylko wykręcić ten maksymalny Gini, czy jakikolwiek tam parametr lubimy, tylko żeby właśnie jeszcze coś tam więcej rozumieć. I rzeczywiście w obszarze antyfraudowym, gdzie jest z jednej strony duża zmienność środowiska i wiemy, że te modele nie są budowane na dziesięciolecia, tylko one są na tu i teraz i za kilka miesięcy potrzebujemy zmiany, bo te paterny fraudowe mogą się zmienić, więc i tak musimy model podmienić. Dwa, że rzeczywiście te grupy fraudowe są niewielkie. Te modele są po prostu trudne do zrobienia. Tam nie ma takich mocnych trendów, tylko rzeczywiście trzeba wychwytywać nisze. To tam wrażliwość i jakby użyteczność tej wysokiej elastyczności modeli ML-owych jest bardzo duża i stąd rzeczywiście w tym zastosowaniu no, widzimy duży potencjał, że warto to zrobić. Raz, możliwość ujarzmienia szerokich źródeł. Dwa, szybkie wytwarzanie modelu, duża elastyczność, wychwytywanie techniczne, to powoduje, że rzeczywiście ML tam fajnie pasuje, ale z drugiej strony musimy pamiętać o tym, że ten model nie będzie stabilny, on nie będzie na dziesięciolecia, musimy monitorować, co jest w środku i musimy mieć szybką maszynę, żeby zrobić podmiany. Cokolwiek zobaczymy, ten model przestaje pracować, musimy mieć już w backupie gotowy, następny przygotowany i po prostu wstawić go na półkę i podmienić. Także to trochę taki, powiedzmy, ten posag modeli machine learningowych, że one mają swoje wymagania. Fajnie działają, ale od razu pojawia się duże maszyny do przetwarzania, dużo większa kontrola nad źródłami danych, czy tam nie ma jakichś ruchów na źródłach danych, możliwość szybkiej generowania nowych modeli i ich podmiany. No to jest jakby ten pakiet, który razem z modelami ML dostajemy. Więc jak się przygotujemy, okej. Jak się nie przygotujemy, no to jest ekspozycja, no niestety, na duże ryzyko.
Mnie ten przykład z fraudem się bardzo podoba. A chciałem do niego dodać jeszcze jeden element, o którym dzisiaj nie mówiliśmy, a może być istotnym, że modele nam nie rozwiążą wszystkich problemów same, bo dookoła tych modeli muszą być ludzie, którzy będą też je rozwijać. I co prawda przypadki fraudów rzeczywiście wymagają bardzo szybkiej adaptacji, ale gdzieś tam jest potrzebny jakiś zespół, jakiś red team, który będzie śledził, czy model dobrze działa, monitorował go. To są już inne umiejętności potrzebne. Już nie potrzebni są modelarze, którzy będą tworzyć modele, ale cały czas musimy mieć specjalistów, którzy są w stanie te modele utrzymać. Bo utrzymanie tych modeli to też nie będzie jeden model, ich będzie coraz więcej. Więc utrzymanie, zarządzanie modelami to są nowe problemy, o których też warto pamiętać, że samo narzędzie to za mało, potrzebni to jeszcze specjaliści.
Otworzyłeś puszkę Pandory.
Tak, tak.
Na koniec.
Tak, ale nam czas się kończy. To już może tak ostatnie tylko już pytanie takie na zakończenie podsumowujące. Co aktualnie jest takie najpilniejsze, nad czym wypadałoby się pochylić, żeby ten ML i AI mógł tak w miarę sprawnie być wykorzystywany przez firmy fintechowe? Co tak najbardziej teraz wymagałoby uwagi i skupienia? Jak Państwo uważacie? Może od Pani zaczniemy tym razem.
No to już chyba jest dużo wyzwań związanych właśnie z etyką i moralnością, ze zrozumieniem tego kontekstu społecznego i kulturowego. To chyba jakby to są takie dwie dla mnie najważniejsze wyzwania. Pewnie nie tylko dotyczące rynku finansowego, ale ogólnie zastosowania sztucznej inteligencji. No bo ona nie ma wrodzonego poczucia etyki ani moralności. Wszelkie decyzje przez nią podejmowane są oparte na zasadach i algorytmach, które zostały mu przekazane przez ludzi. No i ona nie ma zdolności do rozważania etycznych konsekwencji swoich działań. Czy tego ją nauczymy? Pewnie nie, ale myślę, że na pewno powinniśmy się zastanowić, jaką moc oddawać sztucznej inteligencji.
Dziękuję. Proszę.
Dla mnie jednym z najważniejszych, może najważniejszym wyzwaniem jest kwestia walidacji tych nowych modeli. I żeby nie było zbyt szeroko, to można skupić się na tym, kto powinien je walidować. Wydaje mi się, że nie powinien to być twórcy modeli, bo zawsze jest pokusa, żeby zbyt optymistycznie patrzeć na swoje modele, więc ktoś inny. Ale czy ktoś inny, audytor zewnętrzny, firma, czy instytucja rządowa, czy jakaś inna instytucja, a może uczelnia? I ponieważ jestem tutaj akademikiem, to prawda, mieliśmy taką rozmowę i w tej rozmowie ta współpraca z uczelnią może nie była najlepiej pokazywana, ale wydaje mi się, że tu jest duża szansa, żeby niezależne organizacje, które rzeczywiście żyją trochę innym życiem, pomogły spojrzeć na chłodno na pewne rozwiązania i być może pomogą też wykryć pewne ryzyka. Tak więc kwestia walidacji to jest problem, ale być może jest takie nieoczekiwane rozwiązanie w postaci współpracy międzysektorowej.
Tak, jestem za. Dziękuję. Proszę.
Trochę po kursie, ale kilka rzeczy dołożę. Po pierwsze, dobrej jakości dane. Bez dobrych danych nie będzie żadnych modeli, czy dużych, czy małych, więc w organizacjach, które są data-driven i potem mówią AI, to najpierw jest data-driven. Najpierw musi być data zorganizowane, z jakością testowane, z kontrolą, monitoringiem. To jest punkt pierwszy. Punkt drugi, powiązane z tym, co wskazujesz, jakość modelarzy, ich doświadczenie. Ci ludzie muszą wiedzieć, co robią, muszą rozumieć narzędzia, muszą znać ich ograniczenia. I dodatkowym zabezpieczeniem rzeczywiście taka warstwa walidacji zewnętrzna w pewnych miejscach pewnie nawet powinna być. Gdy mówimy o takich modelach dużych, wrażliwych, oddziałujących na duże populacje, to taki dodatkowy audyt niewątpliwy, ale jak mówimy o rynku masowym, to moim zdaniem, no tak jak od elektryka wymagamy, żeby miał odpowiednie uprawnienia, żeby pracować przy odpowiednich napięciach, to tutaj jak bierzemy się za modelowanie, no to nawet jak mam tam w Excelu guzik prognozuj, to ja powinienem wiedzieć, co on robi, tak? A nie, mimo że te narzędzia są kolorowe, klikalne i tak dalej. No sorry, tak? Jak robimy poważne rzeczy, to powinniśmy rozumieć, co tam się dzieje. I trochę level up na poziomie zarządów. Ja bym chciał, żeby osoby decydujące o procesach rozumiały, do czego te narzędzia są. I trochę znowu, tak jak profesor wskazał, AI za nas nie rozwiązuje problemów. One nam pomaga, przyspiesza, analizuje pewne dane, podsumowuje, ale nie rozwiązuje problemów. To my musimy je zdiagnozować, my musimy je nakreślić. Same AI nie jest po prostu remedium na problemy biznesowe. Ono jest jednym z narzędzi. A po drodze musi być uporządkowanie danych, po drodze muszą być kompetentni ludzie, po drodze muszą być procedury bezpieczeństwa audytu i AI będzie wtedy fajnie działało, będzie wspomagało, ale jakby samo uruchomienie AI, no to nas jeszcze nie uzdrowi i to na poziomie decydentów takie rozumienie powinno być, że to nie wystarczy zamówić taki projekt, czy na zewnątrz, czy wewnątrz i już będzie świetlana przyszłość, 3 miesiące wdrożyliśmy AI i mamy przychody 5 razy w górę. No to tak to po prostu nie działa. Także takiej edukacji i na poziomie ekspertów, i na poziomie decydentów, no ja bym potrzebował, tak żebyśmy rzeczywiście bezpiecznie z AI skorzystali.
Tak, super. Dziękuję bardzo. Dziękuję Państwu bardzo za dyskusję, bardzo ciekawą, interesującą. Żałuję, że nie mamy więcej czasu, ale kto wie, może w przyszłości coś się jeszcze uda stworzyć. Bardzo dziękuję Państwu i na tym chyba zakończymy. Do widzenia.
Dziękujemy bardzo. Do widzenia.
Do widzenia.
Dziękujemy bardzo.